This is the first video in a series on how to wire your hot rod, rat rod, street rod, or custom car. Wiring kits are totally unnecessary, and if you know what you're doing, you can safely wire your dream machine without any problems. The nice thing about wiring your own car is that you will get to place everything where you want to and not where somebody else decides for you. In this video, I will discuss how to safely use a relay to switch high current loads using small micro switches. So let's get started. Hi, I'm John from 1929FordHotRod.com. In this video, I'm going to explain the importance of a relay and why we should use a relay. Relays are nothing more than an electromagnet that pull down a set of switch contacts when the electromagnet is energized. The electromagnet consists of an iron core that is wrapped with a whole bunch of wire called a coil. This coil will have a small amount of resistance depending on the size of the wire that they use. The finer the wire, the more resistance. The heavier the wire, the less resistance. The switch contacts are going to be rated for a current rating, which is usually found on the relay. This relay has an operating voltage of 12 volts and a maximum current rating in the switch contacts that are inside the relay of 30 amps. Do not exceed this 30 amp rating. If you do, you could quite possibly cause a fire inside your car or hot rod or whatever you're using this relay on. Imprinted on the side of this relay, it's showing us the terminal connections for it. So we have connections 85, 86. This is going to be the coil of the relay or the electromagnet. Over here we have 30 and 87. This is going to be the switch contacts, of which have a maximum rating again of 30 amps. On the bottom you can see the terminals are labeled also. This is going to be 30 and 87. That is our switch contacts. Here we have 85 and 86 for the coil of the electromagnet of the relay. I would like to know a little more about this particular relay. So what I want to do is I want to measure the resistance of the coil or electromagnet. To do that, I'm going to use my multimeter. I'm going to make sure the red jack is going to be in the ohms jack where I can make the resistance measurement. Push it in all the way, and I'm going to select the lowest resistance range for the resistance function. So on this particular meter it's 200 ohms. Then I'm going to measure the winding resistance of the coil. Here we're getting 65.8.9, almost 66 ohms for the resistance of the electromagnet or coil winding. Using the information that I found on the relay, the 12 volt operating voltage and the measured resistance of the coil, I can make a few calculations. First, let's review how we would calculate current. Current is going to be equal to voltage over resistance, or I equals V over R. Using the 12 volts as my voltage value and the 66 ohms as my resistance value, I did a quick calculation in the calculator and I came up with a current of 0.18 amps or 180 milliamps. From this you can start to see what's going on with this relay. I only need 180 milliamps to control up to 30 amps. Pretty remarkable. Over here I have 12 volts coming from a power supply up on the bench, and if I connect the positive and negative to the relay, I should hear it click. There you go. So this looks like this relay is working. Now let's measure the current of the coil and see what that gives me. Before I make any current measurements using my digital multimeter, I have to set it up to do that. So this particular digital multimeter has two current ranges. The maximum would be 200 milliamps and on the lowest, and the highest current range would be 10 amps. Now, we calculated 180 milliamps. That's awfully close to the 200 milliamps, so I think I'm going to go with the 10 amp range. So let's set the function range switch to 10 amps. And let's move the red jack from the volts ohm hertz jack plug to the 10 amp plug. I don't need to touch my common jack because that's going to stay right where it is. Remember now, current is through the circuit and voltage is across a circuit. So current is like your gas pump telling you how many liters or gallons of fuel you're pumping into your car or truck. So to do this, what I'm going to do is I'm going to connect a negative lead to the one terminal of the relay. The positive lead will go to the positive jack of my positive test lead of my multimeter, and I'm going to take the black lead and connect it to the other side of the coil. So here I heard the coil operate, and I'm drawing 180 milliamps, 170 or 0.17 amps. So it's staying pretty solid at 0.17 amps. Let's just do it a few times. So I've released it, operated it, 0.17, try it again. So it looks like this relay is pretty much within the spec that we calculated. Here I have a couple of automotive lights. This is a dash light that came out of the instrument panel from a GM car. This is another 12 volt light. Let's just see what they do. They should light up. There, this one does. Let's measure the current and see what we get. So I'm already set up to measure current. So I'm going to connect the red lead from my power supply into the red test lead of the multimeter and take the black lead. Now so you can see current is going through the meter. I'm going to complete the circuit with the other side of the meter lead. And you can see this particular light bulb is only drawing 160 milliamps. Let's see what this other light bulb is going to do. It's a little wee bit bigger. So this is the ground terminal. So much brighter light bulb, and it's drawing 0.94 or almost 1 amp of power. Now let's wire up the relay to control these two light bulbs. So I'll first start out with this little dash light, GM dash light. So what I'm going to do is I'm going to connect power to the relay and leave it there. So this will be power on the one side of the coil, and this will be my ground connection, so this will be like a push button switch on the dash. So there's my relays working. So now let's connect up the relay to the light bulb. So what I'm going to do is I got to connect power using this clip lead to one side of the switch contacts, like that. On the other side, I'm going to connect, the other side of the relay will now get connected to the light bulb. Now to complete the circuit, I need a ground connection. So the ground can become common. So this will be my ground on the relay, right here. So as soon as I complete the circuit with the ground, this light bulb should be turning on through the relay. Let's replace this GM dash light with the brighter bulb. So this is going to be my ground connection. Usually on most North American cars, ground is the body or the chassis of the vehicle. Let's connect it here like that. And now, using the ground connection, I'm going to complete the circuit using the relay. So there, the relay comes on and turns on the light bulb. So now I'm using about 180 milliamps to control 1 amp of power. I could replace this light bulb with the headlight bulb of my hot rod or car. I could replace this light bulb with a fan motor, say for example the cooling fan if it's not going to draw more than 30 amps. Or any other number of devices that draw a little bit more current. So now let's explain how I actually connected the relay to make this all happen. So we have here a simple circuit diagram. This is the 12-volt power supply, my bench supply. I wired the red lead from the bench supply, that's this one, to the terminal labeled 85 on the back lug of the back terminal of the relay. Then I wired this, became my on-off switch. So this is this on-off switch right here. So this is where I was touching terminal 86 to make the relay work. Now to get the circuit working for the little light bulb, this is the light bulb that I used. So there's the symbol for a lamp, and the relay contacts, the switch contacts, were terminals 30 and 87. So what I did is I brought terminal 30 back to 86, and I then connected terminal 87 to one side of the lamp, and the other side of the lamp came back to my power circuit. In this case, I connected it to terminal 85. So this is how I wired it up to make that particular circuit work. Now we're still missing a few things if you wanted to use something like this in your car. And I'll show you what those things are.
This is a simple circuit diagram that I drew up using a relay to control the headlights on your car. This circuit has two fuses, fuse F1 and fuse F2. Fuse F1 will have a very low current rating and will protect the relay circuit. Fuse F2 will have a much higher current rating and protects the headlight circuit. The gauge of the wire for the coil side of the relay can be quite small, as the relay coil itself draws very little current. Since the coil of the relay draws so little current, I can get away with using an extremely small headlight switch on the dash to turn my headlights on and off. The wire gauge for the switch contacts of the relay, which end up going towards the headlights, should be of a substantial size to handle the current rating of the headlights.
There will be additional videos regarding the selection of fuse sizes and wire gauges, but that's a whole different topic. Feedback and comments are always welcome. Thanks for watching. Please visit my website at 1929fordhotrod.com.